Hi, my name is Fiolka with the Atchison Planetarium and Cranbrook Institute of Science. This week, I'm going to take us all on a journey where literally no one has gone before, beyond our Milky Way galaxy. Whenever we do look around our Michigan sky, all of those stars we see, including the sun, as well as planets, our moon, even ourselves, we are all part of the Milky Way. That's the name we've given to our galaxy, this island of stars, 400 billion of them, spanning a spiral structure so large that it would take a jetliner 200 billion years to cross it. And for centuries, we thought that this was it. Everything we see in our sky was in this one single island of stars. Over time, strange fuzzy patches were discovered, and they were called nebulae. And then during the late 1700s, a French astronomer by the name of Charles Messier, he was a comet hunter by speciality, actually set out to locate and catalog these fuzzy patches so that he and other comet hunters would actually not mistake them for comets. Often they can appear one and the same in a telescope. Certainly he didn't discover all of them. Many were discovered by others, but he still included them in his catalog just to make sure he captured them all. And in fact, some were even added to his catalog after his death in 1817 for a grand total of 110 objects. And even though there have been other catalogs created since, containing literally thousands of objects, Messier's catalog still lives on even now. But it was only in the last century, thanks to the pioneering work of such famous astronomers as Henrietta Swan Leavitt, Edwin Hubble, and Milton Humason, that we've realized that many of these nebulae were not actually nebulae or star-forming regions at all, but they are really other galaxies, other Milky Ways beyond our own, at distances so fantastic they are almost beyond human comprehension. We were able to deduce using techniques such as observing variable stars called Cepheid variables, or observing certain types of supernova explosions of stars in these other galaxies, the true distances, or at least very close to it, of them. Our universe suddenly and dramatically increased in vastness and scope, and even helped us realize that the universe was not static at all, but actually expanding. Today, astronomers estimate that there are 2 trillion galaxies of all sizes and shapes and complexity. Our sky is really full of them, but they are so far away that, with the exception of the Andromeda Galaxy in our Michigan skies, we can't see them with just our eyes alone. Many years ago, there was a wonderful planetarium show that we ran at Cranbrook. It was called More Than Meets the Eye. And it was a perfectly named show, since it's often the case that when you look at a patch of sky, sure, you might see some stars there, perhaps the odd planet, maybe our moon, but that seems to be it. But if you look a little closer, suddenly there are many, many more objects right there where there appears to be nothing at all. If you take the Big Dipper, for example, we see this familiar pattern every night here in Michigan. It's an asterism or picture within the official constellation of Ursa Major, the Great Bear. But there's really a lot more here than just these stars. And it really is a perfect example of a region in our sky where there really is more than meets the eye. So I just wanted to take us on a little tour of some of the hidden galaxies around this region using actual photos taken through our telescope at the Cranbrook Institute of Science Observatory. There are lots and lots of galaxies here, but we're just going to take a look at a few of them. In general, galaxies come in all shapes and sizes. Not all are classic spirals. Some are oval, some circular, and some don't really have any shape at all. We call them irregular. Some of the more exotic ones even shaped like a ring. And sometimes their apparent appearance to us comes from our location relative to them. Sometimes we see them from above, or maybe from the side, and really everything in between. First candidate is this one, called M81, the 81st entry in Charles Messier's catalog. It's also known as Bode Galaxy because it was discovered by Johann Bode in 1774. This galaxy is about half the size of the Milky Way and is 12 million light years away, meaning that the light from which we see this galaxy today left on its journey to Earth 12 million years ago. So we're really seeing it as it looked that long ago. And it works both ways. If there's anyone in that galaxy looking at Earth with some kind of a telescope, well, they're seeing the Earth as it looked 12 million years ago as well. They wouldn't even know that we humans are here, even if they could see right down to the ground on our planet Earth. Look at those beautiful spiral arms of this galaxy. Can you see those pinkish dots scattered around? Well, those are nebulae. Those are star-forming regions, just like the Orion Nebula in our galaxy, but in this other galaxy. So we see the same processes at work in our galaxy across the universe. Located close by to M81, so close in fact that a small telescope will show you both at the same time, is M82. You guessed it, it's the 82nd entry in that famous catalog. It's sometimes known as the Cigar Galaxy. Easy to see why, right? It's actually located so close to M81 in reality that they are gravitationally interacting with each other. Can you see all that orangey red at the center? That's known as starbursts, where there are a lot of stars way above the normal rate being created. The Hubble Space Telescope has detected 197 massive clusters of young stars in the core of this starburst. The trigger for all of this activity? It's the gravitational effects of nearby M81. Let's move away from this region and take a look at this incredible galaxy, M101, known as the Pinwheel Galaxy. I call it incredible because there is an astonishing 1 trillion stars here. Can you imagine a million stars? That's 2.5 times as many stars as in the Milky Way, but packed into a galaxy just slightly smaller than our own. See how we're looking at it? Face down, just like we're flying over the top. The dramatic nature of the vast spiral arms is all too visible, even from 21 million light years away. Can you see that both sides of this galaxy are not quite the same? Well, it's thought that a close encounter happened with another passing galaxy in the distant past, which actually triggered this asymmetrical shape. Our final candidate for review is technically part of the neighboring constellation of Canis Venatici, but it's close to the Big Dipper, so we'll include it. It's known as M51, better known as the Whirlpool Galaxy. At 23 million light years from Earth, well, we are really pushing our boundaries even more. Sometimes this galaxy, which is actually about 76,000 light years across, is also called M51A. The reason, well, see that little blob-like structure next to it? That's M51b. It's actually another galaxy that has and still is interacting with the main galaxy. You can see that amazing bridge of stars and interstellar gas and dust between the two of them. The interaction has greatly distorted the shape of the smaller galaxy and increased the distinctive spiral shape of the other. These galaxies are closely studied because they are great examples of how galaxies move through the universe and sometimes even run into each other in the process. We know a similar fate awaits the Milky Way some 4 billion years from now when the Andromeda Galaxy is going to crash into it. So once again, we see similar processes in action throughout our amazing universe. Very often, when we were in our Cranbrook Observatory entertaining our visitors on a clear Michigan night, or using our photography equipment to capture images of distant objects, our telescope, well, it looks like it's pointing at nothing. But take a look through it, or take a sequence of photos, and suddenly there is something there. A galaxy, a star cluster, a nebula. So, when we reopen once more, please come by and take a look for yourself. Thank you for watching, and happy stargazing.